welcome back to the channel. Today is July 19 and we're solving lucky numbers in the matrix. This is actually the second time I solved this question, so I put it solve here because the previous recording doesn't work. Anyways, this is an easy question, but it's not very easy. So let's look at the question. So given an m by n matrix of distinct numbers, return all lucky numbers in the matrix in any order. So lucky number is defined by the element of the matrix such that it is the minimum elements in the row and the maximums in the column. So let's look at some example here. Right. So this is a given example. 3, 7, 8, 9, 11, 9, 13, 15, 16, and 17. So the result here is 15 because 15 is the minimum in its row and its maximum at its column. So 16 is not the minimum in its row. It is the maximum in its column. So it is not a lucky number. So the only lucky number here is 15. So let's go over a thought process. So the thought process of this will be you're keeping track what is the max element of each column. And then we go into the rows and check if there are the minimums. All right. So here I define a max array. And then you can see I'm doing 2 here because what am I trying to do is for each column, I try to find where the maximum is. And then I store the index of that row into the max array. So later, if I want to check this, right, I pop this out or I look at this, it's 2. So I go to index 2 and then I check what is the minimum of this row. If the minimum of this row is equals to is equal to 15, right? And then I know that 15 is the lucky number, and then I want to add it to the result. So let's look at this. We do column 0 first, and then we do column 1, and then we do column 2. So notice that the length of the max array will actually be the same as the length of the columns because we're storing one index for each columns, right? So after we're done processing it to store index of the max for each column to max array, now we can do the stuff and check if there's a minimum, right? So if you look at this, it said, oh, the max of this column lies as row 2. So I'll just call it row, right? I just go there and say, oh, minimum of matrix 2. So it will give me the minimum of this row, and then just like, oh, they'll tell me this is 15, and I was like, oh yeah, actually it's the same as whatever maximum I have for the column. So I'll add that to the result, and then I go on here, it's also 2 in this case, and then like, oh, this is actually not the maximum, not the minimum for the row, it's a maximum for the column, right? So let's say if I swap 16 and 11, so I will have a 1 right here because 16 is at row 1 in this case if I swap. But we can notice that if we call mean on this will be 9, 16, and 13, which 9 is not equals to 16. So you want to add that into the result. So we go on and then go to the end of the length and then check it in this case. Okay, let's dive into the code. So in the beginning, I said I will define a max array. I will also need a result array, and we can call rows equals to the length of the matrix, and then columns is equals to the length of matrix and index 0. So we look at this row and see what's the length of it, right? So now we can start by finding the max of each column. So in this case, we can just go through each column for column in range of columns. And then we can define maximum. And then we define an index because we want to find index 2, right? So going through each of the rows. And then we set if the matrix of the row, I think this should be row instead of rows, and column is greater than maximum. We want to update the maximum to be equals to the matrix at this row and column. Oops. And then we want to update the index to be the row, because that is what we're looking for. So at the end of every column, we want to append it to our max array about index. Now we're done with this, right? Now we're done with the max. Now we're processing the max array. So processing max array and find the corresponding row, right? So we do for I in range of max array, length of max array. We also, this is also same as the length of the columns, right? Because we said this is the same as we need how many more the columns is, and then we store each of the max index into it. So row will equals to the max array at I. This is what each of our elements store. And then we set the minimum equals to the mean of that row. So if we set if minimum is equals to the matrix of row and then I, since this represents which column it is, right? And then this is going through each of the columns. And then we can append it into the result. I think this will be the same. This will be the same as minimum because they're already equals, right? At the end, we just return the result. In this case, so if we run this, row is not accessed by anything. Oh, wrong typo here. So run again. Accept it, and then we can submit. And then this time's 114 milliseconds beats 42.19%, and then the complexity will just be of n squared because we're just going through the number of every element. It should be of m by n. If m and n are different, there will be m by n, and then the space complexity will just be the max array. It will be all of the length of the columns, how many columns that is. All right, thank you for watching today, and I'll see you all tomorrow.